Well, thank you for joining me on exercise 2A. We're going to be looking at question 2, which says to use calculus techniques to determine the exact coordinates of any stationary points on the following curves, and use the second derivative test to determine whether the maximum, minimum or horizontal inflection. So we've got our function y equals x squared minus 12x plus 40. We know it's a quadratic, which has a minimum because it's got a positive x squared, but never mind. Let's get the derivative, which is 2x minus 12, because that's 12x to the power of 1, that's x to the power of 0, and that's a 1. So you go 1 times 2 is 2, and you drop the 2 down to a 1. You go 1 times 12 is 12, and you drop the 1 down to a 0, and you go 0 times 40 is 0, and so you end up with 2x minus 12. So that stationary point happens when the derivative equals 0. That's the turning point at the derivative is 0. You've got a gradient of 0 there. So 0 equals 2x minus 12. So take the minus 12 across to be positive 12. Take the times 2 across to be divide 2. And therefore you get x equals 6. To find the y value, because it's a point, we substitute the x equals 6 into the y equation. So you got 6 squared minus 12 times 6 plus 40. 36, take away 72 plus 40. 76 minus 72 is 4. So there is a stationary point at 6, 4, and we test that in the second d2y dx squared, which is d2y dx squared is the derivative of the first derivative. So we've got 2x, 1 times 2 is 2, and that's x to the power of 0. So we've got, that drops down, and we've got a 0 times 12 is 0. So we end up with just 2. Since it's 2, therefore it's positive. And if it's positive, it means concave up. And concave up, therefore, it's a minimum stationary point. I hope this has helped. Until next time, stay happy.